All right, guys. So in this lesson, we're going to be talking about graphing linear functions, and we'll get into horizontal, vertical lines, and into parallel and perpendicular lines. Again, feel very confident about this. You've done all this stuff before. So it says to plot points here, but I'm just going to use your understanding from your middle school days and Algebra 1 days that if they give this to you in slope-intercept form, right, so that mx plus b, the way that I'm going to do this is, I'm going to plot the y-intercept first. All right, so this right here is the y-intercept, so 0, 6. Then I'm going to use the slope of negative 3/4 to plot more points. So I've got, I'm going to go up 3, 1, 2, 3, and then because it is a negative slope, I've only moved in the positive direction in the y value, so I need to move to the left for a negative direction to get a negative slope. So 1, 2, 3, 4. Do the same thing going the other way from the y-intercept. Go down 3, but then right 4. I'm going to keep doing that until I run out. So it looks like that is my line. All right. Now we can do the same thing here on this next example. All right, using that y-intercept of 5, so 0, 5, and the slope of negative 2/3, so up 2, then left 3, all right, and then down 2 and right 3. And then make your line. Notice that both of these that I've done so far, the first two, both have negative slopes. So as we talked about in the last video, if you're thinking from left to right, it looks like it's going downhill. All right, so here's a few. I know it's kind of hard to see with all the, it's pretty small here, but this just shows you some vertical stretches, compressions. So that's where your number in front of your x, which is your slope, is going to change kind of what it looks like. Again, as we've talked about in the past, if you ignore the negative, if there is a negative, ignore it, right? That's going to be that reflection, or in this case, change it from going uphill or downhill. If you just look at the number, right, 2, 3, 4, that's going to be what we call stretches. They're going to get steeper. And if you look at like 1/2, 1/3, 1/4, 1/5, getting smaller in terms of between 0 and 1, that's going to make them less steep or flatter. All right, with vertical shifts, they're gonna look exactly the same. So all parallel lines here, but they're just gonna move up and down based on the new y-intercept. So same idea here, right? If I were to graph the original function or the parent function from your toolkit for f of x equals x, right? It looks something like this. That's a y-intercept of 0, a slope of 1. And then if I wanted to graph this new one, right, my transformations, first thing I notice is we're moving 3 units down. So I'm going to be starting here. But instead of having the same level of steepness or the same slope, that 1/2 is going to be a compression to make it less steep or flatter. So instead of like going up 1, right 1, you go up 1, right 2. And you notice this is going to make our line look a little bit flatter. All right, so it's not really something that you need to, I'm not that worried about you understanding, but it is good to know, understanding how the slope, that number in front of x, is going to change how the line looks. Same thing here. Let's try this one. I'm going to just reorganize this so that it's in slope-intercept form. So 2x plus 4. Let me graph that parent function again. So slope of 1. Okay, so there's the slope of 1. And then in terms of my transformations, I'm moving 4 units up. So there's my vertical shift. And then this time, instead of 1/2, it has a 2. So that means instead of going up 1, right 1, I go up 2, right 1. So that's going to be what we call stretch. I'm going to make this green line steeper than the parent function. And you can see that it is definitely steeper. All right. So let's do some identification here, right? I'll try to match up the colors as best I can. So Roman numeral 1, right? If I look here, Roman numeral 1, we have a slope, or excuse me, a y-intercept at 0, 3, and our slope is positive and it's going up to right 1. So I'm looking for a y-intercept of 3, and I'm going up to right 1. So this looks like Roman numeral 1. What color is Roman numeral 2? It's like a light blue. Let's see if we got light blue here. So Roman numeral 2 is the same y-intercept, so it's going to be C or D, but this time it's a positive slope that is less steep or flatter, so it's being compressed. It looks like that slope is 1/2, so this is going to be Roman numeral 2. Then number 3 is kind of a turquoise. I don't really know if I have that one. I guess I'll go with this. It's kind of like a green. And that y-intercept is at -3 with the same +2 slope. So this is going to be Roman numeral 3. And finally, 4, I'll just call that like a navy blue or almost a purple. And this has a y-intercept at +3, but a negative slope in terms of that one. So -2 is the slope. So that's Roman numeral 4. All right. Okay, so let's do a few examples on how to find the x-intercept, something that you would have done in your algebra classes. Essentially, when you find intercepts, you're finding where your function is going to cross the axes. So for the x-intercept, right, since you have an x value, your y is actually 0. So that's why when you find your x-intercepts, you're going to replace f of x, which, as we talked about, right, is the same as y, with 0. So when I solve for each of these, I'm going to write 0 equals 1/4 x minus 4 and then solve. Move the -4 over to get a +4. To get rid of that 1/4, we're going to multiply both sides by 4. And then I'm going to multiply both sides by 4 to get x equals 16. Now this one here, finding the x-intercepts, I'm going to do the same process, setting that y equal to 0. Move the -3 over to get a +3. All right, you multiply 2 by both sides, you get x equals 6. I guess I should write, just so you understand, right, these ordered pairs would be the x values have that 16 and 6, and the y value is 0. So it would be on the x-axis, right? It intercepts the x-axis. That's why it's called an x-intercept. Okay, let's talk about horizontal and vertical lines here. Again, if you're having trouble with this, just remember you have done it, right? So it'll come back pretty quickly if you've already forgotten, right? So we have a horizontal line will consist of a constant output or y value, and a vertical line will always be that constant input on the x value. And the way I've always had students think about it is when you're looking at how to write them is your horizontal line will always be y equals a number, and your vertical lines are always x equals a number. So that should help you understand that you have the constant y or the constant x. All right, so if we want to look at these examples here on A and B, right, this is going to be y equals -4 because it's horizontal. And this vertical line is going to be x equals 7 because all of the points on that line here in letter B, all of them have 7 in their x coordinates. Same thing in letter A. All of the points on that line have a y value that is -4, no matter what the x value is. Okay, now in terms of parallel and perpendicular lines, right, two lines that have the same slope but different y-intercepts are parallel, they'll never touch. And perpendicular lines, the only thing that must be true for perpendicular lines is that they must have opposite reciprocal slopes. All right, and if two lines have opposite reciprocal slopes, that means at some point they're going to intersect and create what we call a right angle or 90-degree angle, which you can see in this kind of image here. Okay, so the key thing you want to remember for parallel lines, same slopes, but different y-intercepts, right? If they had the same slope and the same y-intercept, they'd be literally the exact same line. So same slope, different y-intercept for parallel. Perpendicular lines, the only thing that must be true, don't care about their y-intercepts, they must have opposite reciprocal slopes. So you've got to flip it and change the sign. Okay, so look at these four here, right? We've got these four here, which have f of x and j of x, right? So I'll do these two in green. So f of x and j of x have the same slope, but different y-intercepts. So f of x and j of x are parallel. Okay, and then in terms of the other two, you'll notice that g of x and h of x, again, I don't care about their y-intercepts here. I notice that their slopes are opposite reciprocals, right? One's positive 1/2, the other's negative 2. So g of x and h of x are perpendicular. Okay, so now let's use that information to help us do a few more problems and then we'll be finished. All right, so this first one here says we have a function 2x minus 4. Write an equation for the line passing through the origin, right? 0, 0 is the origin, that is parallel or perpendicular to this function. So they're kind of making this all about the slope and not about the y-intercept. Remember, parallel lines have the same slope but different y-intercepts. So I'll say this is j of x, which is the same slope but a different y-intercept of 0. And letter B, I'll say, excuse me, k of x. And perpendicular lines have opposite, so negative, reciprocal slopes. In this case, the same y-intercept of 0 that I just used. All right, this last one. This is probably the most common type of question you would have seen in discussing parallel and perpendicular lines in algebra. So we have a line passing through 2 points. Find the equation of a perpendicular line that passes through a different point, 6, 4. So let's first find the slope. So I always think of like step 1 is find the slope of the original line. All right, so in this case, I'm going to do the change in y on my original line, which is -3 minus -15, over the change in our x, which is 2 minus -2. So that's going to be -3 plus 15, which is positive 12, 2 plus 2, which is 4. So my slope of my original line is 3. But I want a new line that's perpendicular to this one. So the slope of the new line, right, is going to be m equals negative, right, opposite reciprocal, so -1/3. So that's kind of the way that I do this. So now I have my new slope. I've got my new point, 6, 4. So I'm going to use point slope form to finish this. So y minus y subscript 1 equals m times x minus x subscript 1. So y minus 4 equals -1/3 times x minus 6. Again, if this just said put it in point slope form, you could be done here. But most teachers will want you to do the algebra to get to slope intercept form. So we'll go ahead and take the a few steps to do that. So -1/3 x plus 2, and then move the -4 over with your addition to get +6. So this is our new line that is perpendicular to this original line. All right, and that's it for these notes. Don't forget to try those practice problems.